From above, Greenland looks exactly like we expect it to, a silent, frozen wasteland. During brutal Arctic winters, this landscape seems utterly devoid of life. Beneath the snow, the water is sealed off by nearly 60 centimeters of solid surface ice. It is a sheer, physical barrier, thick enough to stop the wind, the cold, and even the sunlight. But a drone flying over this environment captured a structural anomaly. In real time, a thin, dark fracture formed across the pristine white surface. Seconds later, the ice around that crack began to shift. The massive weight of something moving directly beneath the surface forced the frozen layer upward. Suddenly, the freezing water exploded. A giant animal tore right through the 60-centimeter roof. An animal of this scale requires a massive amount of energy to survive. Finding it here suggests that the water below is far more productive than the surface suggests. To understand how that is possible, we have to look past the rocky surface world and into the deep, dark marine environment below. That 60-centimeter layer of ice acts as a regulatory ceiling. By locking the ocean away from the atmosphere, the ice shields the water column from extreme temperature drops and violent winter storms above. Beneath those massive, glowing glacial structures, a highly interconnected and diverse marine ecosystem continues to operate, completely hidden from the sky. These species remain here year-round, actively hunting and navigating through the most brutal stretches of the Arctic winter. That massive whale breaking through the surface represents the apex of a permanent, thriving biological network. Surviving down here requires a highly specialized set of biological tools, because the primary threat to this ecosystem is the extreme energy depletion that comes with severe winter food scarcity. This chart illustrates the first survival mechanic, metabolic depression. To conserve energy, marine species deliberately slow their internal functions, dropping their baseline energy rate to a stable hum. They also adapt to darkness, relying on cellular clocks to maintain metabolism when sunlight hits zero. Then comes thermal resilience. Their cells function in near-freezing water, keeping tissues active without a biological shutdown. These three biological systems must operate in perfect simultaneous balance. Failure to regulate its energy, its light response, or internal temperature results in immediate systemic collapse. Enduring the winter beneath the ice requires a highly active, tightly coordinated biological strategy. When you look out at these scattered ice floes drifting on the ocean surface now, the boundary takes on a different meaning. The Arctic winter does not hit pause on life. It simply forces the animals living here to change their operating rules. That explosive breach through the thick ice is simply a normal daily function of this highly adapted ecosystem. The isolation seen from the sky masks a complex, enduring biosphere that waits out the season in the dark. The silent, frozen surface of Greenland is the protective cover of a massive,
Following the
hidden
drone's
world.
path, the surface of Greenland stretches out as an endless, fractured expanse of white. From this perspective, it appears entirely desolate. The air temperature routinely drops well below zero, driven by relentless, scouring winds. For almost any terrestrial organism exposed to these metrics, this surface is rapidly fatal. Yet that frozen crust is deceptive. Directly beneath millions of tons of solid ice, massive volumes of liquid water are continually moving. This creates a striking biological paradox. The environment beneath the ice houses a fully functioning, predatory marine ecosystem. When we plunge below the surface, the rules of the environment invert. The ice is no longer the ground beneath our feet. It becomes a solid, locking ceiling. In this pressurized, near-total darkness, marine animals carry out the basic requirements of existence. They must constantly hunt for food, and they must breathe. Accomplishing this requires solving two distinct, lethal problems: the absolute drain of body heat into the freezing water, and total isolation from the atmosphere. Surviving here requires highly specialized biological engineering to actively counter the extreme temperature and the lack of accessible oxygen. The first immediate threat is the water itself. Because salt water can drop below the freezing point of fresh water without solidifying, it rapidly pulls thermal energy away from warm-blooded mammals. To counter this, these species deploy dense layers of specialized fat, serving as heavy biological insulation. This thick barrier isolates internal organs. It allows the core to generate heat and reflects it inward, even as the exterior skin drops to near freezing temperatures. Without this specific adaptation, a mammal placed in these waters experiences cascading organ failure and severe hypothermia within minutes. This specialized fat functions as critical thermal armor, making movement and hunting possible in an environment that would otherwise be lethal. Generating heat requires fuel, and winter hunting expends massive amounts of calories. In response, biology offers a secondary, passive tactic: extreme energy conservation. Certain species cease almost all physical activity. They suspend themselves in the dark water, hovering in near stasis for months during the darkest parts of winter. The biological economy here is strict. By reducing kinetic movement to absolute zero, the animal drastically cuts its internal caloric burn and lowers its thermal requirements. In the tight energy budget of the Arctic, motion is an expensive luxury. Perfect stillness is an active survival strategy used to stretch limited physiological reserves. Even with thermal regulation, these creatures face a harder biological bottleneck. The solid ice sheet entirely blocks access to atmospheric oxygen. Unlike marine mammals in open oceans, animals here cannot simply swim upward to take a breath. They are operating in a closed system. Survival depends entirely on finding rare, temporary micro-openings, where the shifting ice crust has cracked just enough to expose the air. This turns respiration into a continuous, active hunt. Navigating the dark, freezing water to find these specific, shifting vents is a persistent geographical requirement. The stakes are absolute. If an animal fails to locate one of these narrow fractures before its internal oxygen runs out, it will drown, regardless of how well insulated it is. Beneath the ice, taking a single breath is never guaranteed. It is a life or death requirement that must be satisfied continuously. Maintaining life here requires a flawless biological balancing act. These creatures must sustain deep thermal regulation while constantly engaging in a high-stakes hunt for air. These species have evolved to dominate an extreme niche, thriving in conditions that would kill most life forms. Because of this mastery, the hidden ecosystem remains stubbornly active. Predators continue to move, hunt, and navigate dark waters throughout the harshest winter stretches. Extreme environmental constraints do not halt life. Instead, they force biology to engineer more resilient, specialized solutions. A stark contrast exists between the apparent desolation of the frozen surface and the vibrant, biological reality operating right below it. Researchers studying these ecosystems see this hidden world as proof of life's capacity to adapt to conditions that defy standard biological logic. An ecosystem that remains entirely silent, totally hidden from the surface, and yet perpetually in motion. The active biological systems functioning beneath the surface drive the reality
of the
of the
ecosystem. We start with objective data. This region is undergoing rapid shifts. This visualizes the foundational data: total ice lost from the Greenland ice sheet. The loss isn't steady. Greenland's ice is melting at an accelerating rate. This steepening curve represents physical space, and every year more of this frozen world disappears, systematically reducing available habitat. This measurable reduction in physical space dictates new terms for survival across the entire system. This ice functions as a load-bearing infrastructure grid. It provides the physical platforms and transit systems the ecosystem relies on to function. As the ice thins, that infrastructure fails. Established hunting routes physically collapse, severing critical transit corridors. Eroding platforms also eliminate sanctuary. As the edges of the grid dissolve, stable breeding areas shrink until they can no longer support the population.
The physical ground is literally disintegrating. Because of this structural failure, survival becomes harder, even for species perfectly adapted to the cold. If the top layer of this infrastructure grid is failing, where does the ecosystem go next? If horizontal expansion across the surface is no longer mathematically possible,
there is only one remaining spatial vector left on the map. Life shifts its focus downward, moving entirely beneath the ice. Drone footage has revealed this hidden subsurface world, a perspective on the struggle for survival that most humans never see. This move below the surface is a relentless biological adaptation to a landscape that can no longer support weight. Down in the dark, icy water column, the ecosystem adjusts to these new parameters. This is a world still fighting to survive beneath the ice, quietly, relentlessly. This flowchart models the complete causal chain we've observed. It begins with the primary environmental trigger, accelerated melt. That thermal shift causes the direct physical consequence, surface infrastructure collapse, and the loss of that physical space leads to the final biological resolution, subsurface endurance. Because this struggle happens entirely out of sight, it is easy to assume the ecosystem is failing, and sometimes it breaks through the surface, reminding us that life always finds a way. Even in environments that appear utterly frozen and lifeless from above, the logic of adaptation ensures that life continues